my heart's gone and I've got a machine in there, and it's like, wow. It was just a feeling of loss, of like not being a person.
That the intellect and the will in human beings is not in the brain.
So from there, and having developed techniques that I felt good about, I put them on the heart, and bingo, they worked.
So what we're finding now is that we have a form of intelligence focused in the heart.
The brain and the heart are interconnected by multiple sources of information.
To be able to say that the heart has a functional brain.
The heart may be, based on current science, a sentient, thinking, feeling, remembering organ. That's the story.
Did you once instinctively felt that your heart was much more than a blood pump or an organ associated solely with emotions? Did you know that your heart has an incredible, unique intelligence unto itself? Is it true that as in the Holy Quran we understand or realize the reality of things with our heart? Allah says, "Have they not traveled through the land, and have they hearts wherewith to understand and ears wherewith to hear? Verily, it is not the eyes that grow blind, but it is the hearts which are in the breasts that grow blind." Welcome to our documentary, where we embark on a fascinating journey to explore the intricate relationship between the heart and the brain. Prepare to be amazed as we delve into groundbreaking scientific research that reveals the heart's hidden intelligence.
Wilder Penfield, one of the greatest brain researchers of the last century, made one of the most important contributions to the study of the human brain. Alongside his colleagues, he pioneered a revolutionary surgical method known as the Montreal procedure in the 1930s. This technique allowed surgeons to operate on epileptic patients, destroying brain cells responsible for seizures. Under local anesthesia, patients described their sensations as doctors electrically stimulated different brain areas. This method facilitated the identification of sensory-prone areas and, consequently, in taxones.
Operation on the brain under local anesthesia with the patient still awake and able to respond was based on the fact that it was necessary very often to map out the vital areas on the surface of the brain, such as those that control the hand or vision or particularly speech.
The success of the Montreal procedure led Wilder Penfield and his colleagues to numerous discoveries about the human brain, including regions responsible for certain thoughts and the way memories are stored. Over the following years, they developed sophisticated behavioral tests for preoperative and postoperative evaluations, achieving several other significant breakthroughs. During an experiment with one of his patients, when he electrically stimulated the brain area responsible for hand movements, the patient's hand moved. The brain sent a signal to the muscles responsible for the movement. Dr. Penfield then asked the patient to stop the hand movement while still stimulating the area, but the patient couldn't stop the movement. Despite making a rational, conscious, and cognitive decision not to move the hand didn't respond. This proves that man, with his mind, consciousness, and perception, is one thing, and the brain, with its electrical nerve activity, is another. Patient with consciousness, mind, perception, and will doesn't want to move his hand, but the brain makes a different decision, as it is an executive organ. Therefore, electrical stimulation of the brain, he noted, does not influence the patient's will or modify his or her beliefs. While stimulation can cause the person to move their hand or leg, move their eyes or produce a specific sound, it cannot force the patient to generate thoughts, beliefs, or modify pre-existing convictions. Every time Penfield stimulated the brain, the person would say, "I didn't do that, you did." This means that the patient distinguishes between his or her own will and external stimuli. In some cases, the patient would extend his right hand to stop his left hand, which had been electrically stimulated. This would not happen if willpower came solely from the brain, because it's an executive nervous system, unrelated to decision-making, the mind, or will. Penfield repeated this experiment hundreds of times in numerous surgical operations and eventually published his book, Mystery of the Mind. In this book, he summarized this remarkable research journey, stating, "There is no place in the cerebral cortex where electrical stimulation will cause a patient to believe or decide." In 1988, the Canadian government recognized Penfield's contributions, designating him a National Historic Person. A federal historical marker installed by the National Historic Sites and Monuments Board and Parks Canada stands at the McGill University building named after him in Montreal.
The other thing he noted, which is a fascinating observation that remarkably has gone completely unquestioned in medical science, is he asked, why are there no intellectual seizures? We know about seizures. People can fall down, they shake all over, or you can have milder seizures where you just move a limb, or your face twitches, or where you have an abnormal smell or have visual phenomena. But you never start doing calculus when you have a seizure. And you never contemplate justice, and you never contemplate political science. And the question is, well, if large portions of the brain are devoted to higher intellectual functioning, why don't seizures occasionally make you take second derivatives instead of just jerk your arm? And they never, ever do. In 30 years of practice, I've never seen a seizure have any intellectual evocation. And Penfield asked, why are there no intellectual seizures? So his answer as to why he could not find agency by stimulating the brain and why he never observed an intellectual seizure was that the intellect and the will in human beings is not in the brain. It's not material. The brain mediates it, but doesn't give rise to it.
The term split brain refers to the outcome of a surgical procedure called corpus callosotomy, initiated in the 1940s to treat severe epilepsy. In this procedure, the corpus callosum, a bundle of neural fibers connecting the left and right cerebral hemispheres, is severed to halt the spread of epileptic activity. Although effective in alleviating epilepsy, the surgery virtually eliminates communication between brain hemispheres, creating a split brain condition. The intriguing question arises, if the brain is the source of consciousness, does a split brain result in two independent consciousnesses?
A groundbreaking research study led by UV psychologist Yair Pinto challenges the conventional understanding of split brain patients. The study contradicts the belief that individuals with severed corpus callosum, resulting in little communication between brain hemispheres, exhibit split consciousness. Published in the journal Brain, the research reveals that despite the lack of communication, split brain patients maintain a unified consciousness. Traditionally, split brain conditions were associated with Nobel laureate Roger Sperry and Michael Gazzaniga's work, indicating independent consciousness in each hemisphere. However, Pinto's study, involving tests on callosotomy patients, demonstrates their ability to respond to stimuli across the visual field with both hands and verbally. The findings challenge established views, emphasizing the brain's remarkable ability to maintain unity despite physical disconnection between hemispheres. According to Pinto, the patients could accurately indicate whether an object was present in the left visual field and pinpoint its location, even when they responded with the right hand or verbally. This despite the fact that their cerebral hemispheres can hardly communicate with each other and do so at perhaps 1 bit per second, which is less than a normal conversation. I was so surprised that I decided to repeat the experiment several more times with all types of control. The results present clear evidence for unity of consciousness in split brain patients.
The second line of research was that of Roger Sperry, who is was a Nobel laureate working at Caltech. And Sperry studied split brain patients. You may have heard of these people. They're patients who've had surgery in which the hemispheres of their brain are surgically disconnected. We actually cut through a fiber bundle between the hemispheres so that the brain now really is two brains, essentially. There are connections deeper down, but they don't connect the hemispheres very effectively. And this is done to stop seizures. There are rare kinds of seizures that start in one hemisphere and spread to the other that if you can disconnect the hemispheres, the seizures are much milder and much easier to live with. So these operations have been done really since the 1930s, and they work very well. And Sperry took these patients and he studied them in detail because he wanted to ask what happens to someone's mind when you cut their brain in half. And the remarkable result of Sperry's work isn't what he won the Nobel Prize for. He won the Nobel Prize because he found a whole bunch of subtle perceptual changes, very, very interesting things. The remarkable thing was that he had to do Nobel Prize level research to find any difference at all. That is, I've known many of these patients. I've done the surgery. These are normal people. You meet them, I talk to them, their brains are cut in half, but they're still one person. They're completely unitary. They don't have two minds. They don't have two intellects or two wills. None of that. The only differences they have are subtle perceptual things. For example, the left hemisphere is usually the speech hemisphere. And if you have your brain cut in half, only something presented to your right visual field, which is the visual field that your left hemisphere sees, can you speak about. You can't speak about things in your left visual field that your right hemisphere sees because your right hemisphere doesn't have speech. Now, what people do is they'll look and they'll cheat, even unconsciously. So there are perceptual differences, and there are differences that won Sperry a Nobel Prize for figuring out, but they're very subtle. Your intellect, your will, your sense of self is still unitary, even though your brain is split in half. So what Sperry showed, in the same way that Penfield showed, that agency and intellect in human beings is immaterial, Sperry showed that the mind is metaphysically simple. It can't be cut. You can't split the mind. But you can split the brain, but not the mind.
The conventional belief is that learning primarily involves the nervous system and minimally affects the immune system. However, living systems theory challenges this notion, suggesting that all living cells possess memory and decider subsystems. This systemic memory mechanism provides an explanation for emergent properties in complex systems. The theory has been applied to controversial observations in alternative medicine, including homeopathy. Notably, it predicts that organ transplant recipients might experience aspects of the donor's personal history stored in the transplanted tissues. The study presents key observations from 10 transplant cases supporting the systemic memory prediction, where recipients exhibited personality changes consistent with the donor's traits, offering intriguing insights into the potential role of cellular memory in transplant outcomes.
Organ donations and transplants, while life-saving, have led to a fascinating phenomenon known as cellular memory. This theory proposes that the cells within an organ carry memories and desires from the donor to the recipient.
I had a bone marrow transplant for stage 4 cancer in the very early 80s. And I was on the transplant unit. And we would sit down at night, all of us who were dying, and most of us were, and talk about things. And the heart transplant recipients were reporting receiving the memories, feelings, food preferences, fears, musical preferences of their donor.
Bill Wool, a dedicated business executive, underwent a heart transplant after a near-fatal heart attack in 2000.
I couldn't have been luckier because I got a fantastic donor, someone super healthy, handsome leading man, good looks, and the fun began.
Initially, everything seemed normal, but subtle changes occurred over time. Bill, who once preferred the urban jungle, found himself drawn to the outdoors after the transplant.
Within months, the man was transformed into an athlete. We have very little idea that this was going to happen to him, but it did. He started cycling, he started working out, he started swimming.
His newfound interests in outdoor activities, cycling and kayaking emerged, marking a stark departure from his previous lifestyle.
Know on certain things that I had no interest or whatever in before, it had to come from somewhere, and it makes sense to me, and I truly believe that it came from my donor.
Upon meeting the family of his donor, Hollywood stuntman Michael Brady, Bill discovered the intriguing connection. Michael's favorite singer, Sadie, became Bill's emotional trigger. This revelation suggested that more than just a functional heart had been transferred during the transplant.
I thought, this heart is just as powerful, more powerful, and does talk to the brain. Maybe we should be paying attention to that. Maybe the brain, even though it thinks it's us, isn't.
The The brain and the heart are interconnected by multiple sources of information. First of all, there's neural connection from the brain to the heart. There's also humoral connections. Okay, hormones will go from the brain to the heart. The heart, in turn, of course, sends feedback back to the brain through pressure receptors and through literally the blood going back.
The heart is a connective organ, a gentle organ. It's a different type of intelligence. I don't know all about its intelligence. That's what we need to learn.
But the heart is the largest generator of electromagnetic signals in the body. In fact, the EKG is 10, 100 times even larger than the EEG of the brain. And the electrical signal from the heart travels through the bloodstream to the brain. And of course, the brain's electrical signal travels back to the heart.
When we just know about the heart and its remarkable energy and its connections with the brain and its neurons and its hormones, if we know that, shouldn't we be asking and here comes the key scientific question, is there another source of intelligence? Is there another way to think? Not instead, but also. The question isn't either or. The question is and. And if we only glorify the brain, we'll never be open to the possibility that another organ thinks.
Rollin McCready, a prominent researcher and director of research at the Institute of HeartMath, has delved into the profound connection between the heart and emotional experiences. In 1991, he co-founded the Institute of HeartMath with Dr. Childrey. Their research explores the heart's role in emotional experiences, intuition, and overall physiological function. In the intricate dialogue between the heart and the brain, McCready emphasizes that the heart and cardiovascular systems send more signals to the brain than the reverse. Although this has been acknowledged since the late 1800s, it has often been overlooked. The afferent signals from the heart significantly regulate the autonomic nervous system and exert profound effects on higher brain centers, influencing perceptions, thought processes, and emotions.
What we found was that the heart is by far the most accurate part of our body that reflects how we're feeling. Our heart is literally beating out different messages that is strongly correlated with our emotional state. It's a scientific fact, even though a lot of people don't know this, that the heart sends more information to the brain than the brain sends to the heart.
Recent advances in neurocardiology reveal the heart as a sensory organ with its intrinsic nervous system, akin to a heart-brain. This system possesses remarkable neuroplasticity, allowing it to learn, remember, and make independent, functional decisions. The surprising findings underscore the complexity of the heart's intrinsic nervous system and its ability to reorganize over both short and long terms. McCready's work illuminates the heart's role beyond pumping blood, highlighting its capacity for intricate information, encoding, processing, and autonomous decision-making.
We now know that the heart sends much more information to the brain than it receives, including signals that can influence perception, emotional experience, and higher mental processes. Dr. Andrew Armour introduced the term heart-brain in 1991. Armour showed that the heart's complex nervous system qualified it as a little brain.
Dr. Andrew Armour of the UCLA Neurocardiology Research Center discovered a sophisticated collection of neurons in the heart that organized into a small, complex nervous system. The heart's nervous system contains around 40,000 neurons, called sensory neurites, that communicate with the brain.
In those days, in the 60s, there was no consideration of the nervous system. The heart was just a pump. And the reason is because people have not had the facility to see the heart in any other form. You look at it and it's a pump, right? And my own bias is that in the last 50 years or so, we have developed the ability, with all the electronics, to record more than just the muscle on the heart, but the neurons on the heart.
It all began when Dr. Andrew Armour was recording a heart from the outside and made a remarkable discovery.
I started to record outside the heart and found neurons that no one had expected before. And I thought, gee, that's sort of nice. I wonder if that could be on the heart, right? So from there, and having developed techniques that I felt good about, I put them on the heart, and bingo, they worked.
The heart itself has a quite complex nervous system, and all the types of neurons and the way they're wired together to be able to say that the heart has a functional brain. And Dr. Armour has pictures of it. I mean, there's definitely a little brain in the heart. And the types of neurons that are in the little brain in the heart have also been demonstrated to have both short and long-term memory, using the same type of techniques that you use to show that neurons in the brain exhibit memory.
This little collection of neurons can retain input function for a little while. So if your heart beats, puts it in, this little guy is still oscillating. So the last cardiac cycle could set up a number of future cardiac cycles. That's memory.
Sensory neurites. Sensory neurites. That's a very technical term. It means they're essentially brain-like cells, but they're not in our brain. They're in our heart. And they are in our heart, concentrated in such a way that scientists now call these cells in our heart the little brain in the heart. But this kind of discovery is so powerful. And what it is that he found, these 40,000 cells in the human heart, because this isn't a metaphor, this is literal. These cells in our heart, they learn independently of the cells in our brain, of the neurons in our brain. They think independently of the cells in our brain. They feel independently of the cells in our brain. So what we're finding now is that we have a form of intelligence focused in the heart that can function completely separately from what we typically know in the brain. The next image that you're looking at right now, this is really exciting because these are some of the first images of the neurons, but they're not in the brain. They're in the human heart.
Peter Houghton, first permanent lifetime recipient of a Jarvik 2000 left ventricular assist device. Houghton's post-implant experiences include changes in faith, a careless attitude to money and a partial ability to plan for the future.
Peter Houghton expresses gratitude for the artificial heart that saved his life. However, he shares the emotional toll of the procedure, noting changes in his emotional landscape. Despite an active life post-implantation, he describes feeling cold-hearted and less sympathetic, struggling to connect with loved ones, including his grandsons. Houghton has also developed a careless attitude toward money. You don't care if you've overspent your credit cards or not. If you don't have any time left, you might as well enjoy it. It doesn't go away. You just sort of control it. What the hell, you think? If I want something, I'll have it. It's taken him some time to plan more than a day or two into the future. 7 years into this, he says that, with effort, he can now think all the way out to 6 months. He reflects on changes of faith. The pump brought about some religious crises, he reports, causing him to think about his devout Catholicism. Questioning the afterlife. Who knows? These are only priests. They're not very good at being challenged on the subject. Houghton wrote up his thoughts in a book, The World Within Me. 5 years after the operation, he went through a period of clinical depression. Several times I thought, better off if I wasn't here. Let everyone get on with their lives. I felt I'd like to put an end to it. But choosing the methods puts me off. Feel cowardly about killing yourself. Randy Shepard received a Syncardia total artificial heart on June 20th, 2013. His heart had been damaged by 2 attacks of rheumatic fever as a child. He describes how he felt after the surgery.
All of a sudden, my heart's gone and I've got a machine in there and it's like, wow. It was just a feeling of loss, of like not being a person, of not being a self.
In light of Houghton and other victims of psychological and cognitive trauma after intervention in their bodies, some scientists fear we are tampering not with a bodily machine, but with the human spirit. We've got to understand the organs and systems coming into our lives. We haven't paid a lot of attention to the psychological or emotional aspects of thinking of ourselves as bodies, says Arthur Kaplan, head of the Department of Medical Ethics at the University of Pennsylvania.
How do they apply to the human heart and why was it given this name? Very easy, in line with the first meaning, which we said that it is the essence of something, at the most noble part of it. Because that is what your heart is. It is your essence, and it is the most noble part of you that carries values like comprehension and consciousness and awareness and thought and love and submission and regret and penitence. It's your essence, therefore. It's your center and it's your most noble part. That's the heart. The heart is also known as al-aql. How do you translate aql, brothers? Aywa, how do you translate aql? Intellect? Yeah. Any other translations? Mind. Wisdom. Okay. So could we say, for example, it's the center of reasoning, al-aql, center of reasoning that we always thought was here? Look at how the Sharia places a huge and noticeable emphasis that the aql that we point to as being here is in fact here, whilst Islam not diminishing at all the role of the brain. This is a no-brainer, because we see people who have accidents where they're knocked hard enough on their heads, lo and behold there are signs of insanity, dementia and the rest of it. It's obvious. But what Islam does do is shift a lot of the attention to this place here. Something that much of conventional cardiology and medicine perhaps is yet to catch up with, and who knows, maybe the coming years we will see more and more of it. And I will give you a glimpse of some scientific research that is being uncovered in recent times. But before I share with you how the Quran and Sunnah say, reasoning is here, consciousness is here, taqwa is here, iman is here, hypocrisy is here. Allah Jalla Jalaluhu said in the Quran, أَفَلَا يَتَدَبَّرُونَ الْقُرْآنَ أَمْ عَلَىٰ قُلُوبٍ أَقْفَالُهَا. Do they not ponder over the Quran, or are there locks upon their hearts? So according to the book of Allah, what is it that ponders? What is it that ponders? It's the heart. Allah Jalla Jalaluhu said, فَطُبِعَ عَلَى قُلُوبِهِمْ فَهُمْ لَا يَسْمَعُونَ. Their hearts were sealed, therefore they cannot hear. Therefore the primary faculty of hearing the correct message is what? This? It's this, according to the Quran. Allah said in the ayah you heard, إِنَّ فِي ذَلِكَ لَذِكْرَ لِمَنْ كَانَ لَهُ قَلْبٌ. There is a reminder in this for he who possesses what? A heart, Allah said. And in another explicit ayah, Allah said, أَفَلَمْ يَسِيرُوا فِي الْأَرْضِ. Do they not travel in the lands? فَتَكُونَ لَهُمْ قُلُوبٌ يَعْقِلُونَ بِهَا. So they may develop hearts that they can understand with. أَوْ آذَانٌ يَسْمَعُونَ بِهَا. Or ears that they may hear with. Listen, فَإِنَّهَا لَا تَعْمَى الْأَبْصَارِ. Indeed, it doesn't blind the eyes. وَلَكِنْ تَعْمَى الْقُلُوبُ الَّتِي فِي الصُّدُورِ. But it blinds the hearts that are in the chests, leaving no room for doubt what is being referred to here. It blinds the hearts that is in the chests. Ajib, the Quran. Huge emphasis on this. وَلَكِنَّ اللَّهَ حَبَّبَ إِلَيْكُمُ الْإِيمَانَ وَزَيَّنَهُ فِي قُلُوبِكُمْ. Allah has beautified Islam in your hearts. And then the hadith. What did the beloved sallallahu alayhi wasallam say? At-taqwa ha-huna. At-taqwa ha-huna. He said piety is here. Piety is here, pointing to his heart 3 times. What do you and I do when we want to say that we've got things going on in our mind? We say, right? Prophet ﷺ is saying, it's the heart. And the Messenger ﷺ, he mentions other ahadith that indicate that the center of reasoning is indeed the heart. أعددت لعبادي الصالحين ما لا عين رأت ولا أذن سمعت ولا خطر على قلب بشر. In the hadith Qudsi, Allah said that I have prepared for my righteous servants in Jannah, paradise, that which no eye has seen, no ear has heard, and no heart could ever imagine. So what is the center of imagination according to the Sunnah? The heart. So it's fascinating. It's fascinating.